there. All right, so today we are going to talk about the binomial theorem. Now, you actually did this in college algebra, hopefully, but there are some new things now that you're a little smarter in pre-calc. You've got a few more tricks up your sleeve, that some things you know how to do. So hang with me. Don't fly through it thinking you already know all of this. Maybe you do. I don't know. Now, the location of this lesson is a little bit weird. I always feel like it does kind of assume you already know about permutations and combinations. And I have permutations written up at the top of this, but it's really more the combinations that we're looking at than permutations. So I don't know, maybe I should fix that. But when we deal with permutations and combinations, or one of the places we do it is with probability. And so Pascal, Blaise Pascal, mathematician, he actually wrote a book on probability. He did a lot with probability. So obviously he's doing a lot with permutations and combinations. And he kind of made himself a little cheat sheet of all the different possible combinations. Now, what you're looking at here might be a new notation for you. And this is more of an upper level notation for combinations. You are probably familiar with this notation, permutations of n items, choose R. So maybe you have 5 things, you're trying to put them in order, and you're going to choose 3 of them to put in order. How many different ways can you do that? Okay, when you're doing permutations, the order is important. But if you're not worried about the order of items and you're just wondering how many ways can I make this happen, then you're dealing with combinations. And combinations look like this when you were in college algebra, N choose R. So this is a different notation that you would find in a higher level math books. And notice that these are not fractions. It's not like 3 over 2 here. It's just a 3 and a 2. You put it in parentheses, and this really just means this with a 3 and a 2. So this is 3, choose 2. This is 4, choose 2, 5, choose 1. That's what that notation is. So when you see that on My Math Lab or wherever, know that that is the same thing as this. Honestly, I don't care which method you use. You just need to know that they're the same. Okay, so let's go back to Blaise Pascal and let's make his cheat sheet for him. Now, in class, we go ahead and create this, and you start to notice some patterns in this, like when you're choosing 0, how many ways are there to choose 0 things? Well, there's just one way. You just don't choose any. So when you set this up, these are all 1s. How many ways can you choose everything? Also only one way. So then these are always 1s. And so starting to notice those patterns is helpful. Now, because you're not in class, we're just going to cut to the chase and we're going to build this on the next slide. So 0, choose 0 is just 1. And then 1, choose 0 is 1. And 1, choose 1 is 1. Okay. Oh, what is that? I held my pen down too long. Sorry. 1, 1, 1. Okay. So now I'm on, this is called row 0, and this is row 1, and now I'm ready for row 2. So this is 2, choose 0, 2, choose 1, 2, choose 2. And it is just a 1, 2, 1. Now I'm going to do row 3. So 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. And it looks like this when you type it in your calculator. And then we just kept doing them. We plugged them in, evaluated in our calculator, and this is what we ended up getting. Now, let's see if you remember from college algebra. How can I keep going? What is the pattern? Do you remember? Because I don't want to have to calculate these, and it does go back to Pascal, create a cheat sheet for himself. Do you remember that any number is always the sum of the 2 numbers above it? Here's a 6, it's the sum of 3 and 3. Here's a 4, sum of 3 and 1. 5, sum of 4 and 1. 10, sum of 6 and 4. Okay, what's nice about that is I can just keep on going then. So if I keep doing that, it's always going to start with a 1. And then I think it's also worth noting, I am now on row 6. Look at this. Anytime, this is a choose 0, this is a choose 1. Anytime you're choosing 1, you always have that many. So this is a 3, choose 1, 4, choose 1, 5, choose 1, 6, choose 1 is just going to be a 6. Now start adding these up. That'll be a 15, then a 20, 15, 6, and 1. Okay, so I don't know who, well, I guess Pascal probably did this first. Then Isaac Newton came along and he was doing something totally different. He was working on binomials and he was looking at taking them to a pattern, to a power. And he was looking for a pattern. So if you take a plus b to the 0, you just get a 1. A plus b to the first is just a plus b. But if you start squaring it, remember our shortcut for squaring things, you square the first term, multiply the 2, and then double it, and then square the last term. Now, as it starts to get deeper into that, now to cube it, well, now I have to take my result here and multiply it by an a plus b, and here's what it ends up being after you FOIL it all out. So ultimately what we're saying is if I were to write this out 4 times and FOIL it all together, here's what I'd end up with. If I'd write it out 5 times, FOIL it all together, here's what I'd have. Now, what's interesting is if you do that, start looking at your coefficients. Here I have a 1, 5, 10, 10, 5, 1. Look at that row of coefficients. Now look back at the previous slide. Look at Pascal's triangle. Do you see that it's the coefficients here are basically the numbers off Pascal's triangle? All right, so now Newton and Pascal, great friends. They can use each other's work. So Newton called this the binomial theorem, and it basically is saying that anytime you take a binomial to a power, it's really going to be, and here's our new notation that you didn't know in college algebra, it is the sum of a whole bunch of terms. And this is what it looked like when you were in college algebra. This is how we wrote it. We just wrote out a whole bunch of terms. And it works like this. It starts off and it's the combination number from Pascal's triangle. So it's an n choose 0, then the next term's an n choose 1, the next term's an n choose 2. However, I'm just going to go grab the term from Pascal's triangle, and I'm just going to know it's a 1, 5, 5, 10, or whatever row I'd want to use. But there's more than just that. There's 3 things involved. There's the Pascal number, and then you take this first term and you take it to the highest power. And then you take the second term and you take it to the lowest possible power, which is always going to be a 0. Those are the 3 things that you're going to multiply. They're the same 3 things right here. You're going to do your n choose r, n minus r. So let's just pretend it was to the 5th. Well, this would be a 5 then. And so you'd start off with an a to the 5 minus 0, which is just 5. So a is starting off at the highest power. B is going to always start off at 0. So that's why we have the r here. But this is a cleaner notation than this right here. Because now to get to the second term, remember how on summations you just increment by 1? So now r is going to equal 1. So now I'm going to do a 5 choose 1 for the next term. And this is going to be a 5 minus 1, so that's now to the 4th. And that's going to be to the 1st. That's what this would be right here. And so this notation is a new notation for your binomial theorem. Now, I want you to notice that because we do start to use this kind of notation more often. But in the end, what we're doing today is really this same thing. So whether you see it like this or see it like this, know that the process is the same. So let's try one. It is going to be to the 5th power, but I have a 3 now, not just a b. So now I'm going to kind of pick up the pace, and just because this is stuff you should have done before, since that's the 5th row, I'm going to use, or the 5th power, I'm going to use the 5th row of Pascal's triangle, so it's going to be a 1. And then your a is going to be raised to the highest power. Your 3 is raised to 0. Plus, next term. You're going to go to Pascal's triangle, grab the next coefficient. That's a 5. The A is going to work its way down in that power. So now it's to the 4th, while the 3 works its way up. It's now a 1. Plus. Now it's a 10. A going to work its way down. Now it's cubed. The 3 work its way up. You have another 10. I'm going to have to write a lot smaller here. And then my A is now squared. My 3 is working its way up. So it's now cubed. Plus, next number is a 5. A is now to the 1st power. 3 is now to the 4th power. Last one, another 1. Now A is going to be to the 0, and 3 is to the 5th power. That's your first step. Your second step is to go math it out. And so that means having to combine any number parts. So I'm going to be combining my Pascal number with my 3 number. So these are both 1s. So that's just going to end up being an A to the 5th. Plus, next term I have a 5 and a 3 to the 1st. That's going to get me a 15. So 15 A to the 4th. Plus, now I have a 10 and a 9. So that's going to be a 90 A cubed. Plus, I have a 10 and a 27. That looks negative, but it's not. So that's 270 A squared. Next one is a 5 times a 3 to the 4th. Who knows what 3 to the 4th is? 81 times 5, 405 A. And then the last one, you have a 1 times a 3 to the 5th, which is, plus 243. All right, we are done. Okay, that was the easy version just to get us warmed up. Let's look at something way fancier. Okay, so the next one. I have a minus sign. I have coefficients. I have a squared on the inside and a cubed on the outside. So this is everything I could possibly do to it. I just did to it. Let's do the same thing. It is nice. It's only to the 3rd power. Don't try to distribute this 3. We do not distribute powers. We're just going to run it through the binomial theorem. I'm looking at the 3rd row of Pascal's triangle. If you peek back, that's the one that's going to have the 3 in it because it starts off at row 0. So the coefficients are 1, 3, 3, 1. So here I go. I have a 1. The 2x is going to be at the highest power, and then I'm going to write it as a negative 5y squared to the 0 plus 3. Then you take your 2x and you work its way down. Negative 5y squared, going to work its way up. So now it's to the 1st power. Plus another 3, and then you have a 2x working its way down. So it's now to the 1st, while the negative 5y squared is now going to be to the 2nd. Plus, now it's a 1, and you have your 2x is going to be to the 0, and the negative 5y squared is now cubed. Now, some things to notice. Anytime you're at this stage right here, these exponents should always add up to the power of the term. Worked up here too. So you have these all add up to 5, 0, 5, 1, 4. Okay, so that's always the case. You start to lose that if you start getting fancier functions like this one, but there's still going to be some kind of a pattern. I will ask you to do the full binomial theorem on a couple problems, but I can't have you do a ton of them because once you get the gist of it, you know what you're doing, and they take a little bit of time still, so I don't want to spend all our time on our test doing that. So what I'm going to do instead is I'm going to ask you some additional questions where I'm just asking for a single term out of the whole thing. So what I have here, and I know you don't have this in your notes, and I don't know that you necessarily need to write this. Let's just look at the pattern here. Maybe up here, you can just write what we come up with. But when I take this to the 5th power, we've already talked about how these will always add up to whatever that power is. That's an important feature. The other thing we need to pay attention to is what's happening with the combinations. Notice the new notation I'm trying to practice using so that you're familiar with that. Okay, so this is a 5 choose 0, then a 5 choose 1, 5 choose 2. All right, what I am looking for in this example, it says find the y to the fourth term. So the y to the fourth term looks like it's going to happen right here. Here's my y to the fourth. So I'm trying to figure out how would I get this entire term if all I know is that the y is supposed to be to the fourth power. Okay, so let's look at this. If the y is to the fourth, that means I'm going to take this full term here and take it to the fourth power. But remember, if these have to add up to 5, doesn't that automatically mean then that this part will have to be taken to the first power then? Okay, so then the next thing is how do I know which combination to use on this? Well, if you look through these, this number and this number will always match. So if I know that this is going to be a 1 so that these will add up to a 5, then if that's a 1, then I know that's a 1. And so then what I'm going to end up doing to find the y to the fourth term, I am going to pick this piece out. You cannot do the whole thing. I'm going to make these obnoxious. You're not going to want to do the whole thing. You're going to want to look for this pattern. So I'm going to sneak it over here on the right. I know that we've already done it, but my thinking process, I'm going to go through the thinking on it. When I'm going to do this, if I want the y to the fourth, I know I'm going to have some sort of a combination here. And then I know my 4y is going to be to the fourth power, which means my -3 has to be to the first power. So they add up. And that means I know it's going to be a choose 1. And of course, it's a 5 because we're to the fifth. Okay, then I'm just going to go to my calculator. Now, hopefully, in college algebra, I know you just typed it all in your calculator, but by now, I'd like you to know that 5 choose 1 is just 5. Times 4 to the fourth power. Do you know what that is? All right, it's a 256. Y to the fourth. And then times -3. Now you can multiply those together. I would probably just do -15. I would do the two small numbers, take it times 256. I end up with a -3,840 y to the fourth. Okay, you do the next one on your own. Pause the video. Notice I made it obnoxious for you. It's to the 10th power. It doesn't matter. Yes, it's going to end up with a great big number right here, but that's okay. It's really doing the same thing that we just did. Okay, you're finding the x to the 6th term. See what you can do with that. Pause the video so that you can have time to finish it. Okay, that wasn't very nice of me. I gave you kind of a tricky one. Did you catch the trick here? So if I want the x to the 6th term, all right, first of all, I'm going to have some combination number. I know that. It's going to be a 10, but I don't really yet know what it's going to be. Choose something. But I know that my 2x to the 3rd needs to be raised to a power, and my 5 needs to be raised to a power. I want to find the x to the 6th term. Well, I am not going to put a 6 on the x because it's already cubed. If I want the x to the 6th term, I would only want to put a 2 here. That's going to make that be an x to the 6th. And if that's a 2, then this actually has to be an 8 so that they add up to 10. And if that's an 8, then that means this over here is going to be an 8. All right, so now let's go to our calculator. Now, there is a shortcut. I don't know, you might want to try it. You can do alpha window, and it brings up kind of just these function keys, which is kind of a shortcut to doing your combinations. And you would want number 8 there. So then I could do my 10 and 8, 10 choose 8. Then I'm going to take it times. And then in parentheses, well, heck, I can do this in my head faster than typing all the parentheses. Forget the x cubed, just do 2 to the second. Well, that's a 4. I can do that. You can do that. So take it times 4. And then I'm going to take it times, all right, now this one I can't do. 5 raised to the 8th power. So if I multiply that all together, I end up with a 7, 0, 3, 1, 2, 5, 0, 0. And then I put in the variable part, x to the 6th. Okay, let's try one more type. This is similar, but I'm asking a little bit of a different question. This time it says find the 4th term, not the x to the 4th term. That means something different. The 4th term, okay, so in the example I've given you, here's your 1, 2, 3, 4th term. All right, how do I know what the heck to put in here if I'm doing the 4th term? Well, here's the trick, is it will always start off with a choose 0. So since it starts off with a choose 0, the 4th term will end up at a choose 3. If I was asking for the 5th term, it would be a choose 4. If I wanted the 6th term, it'd be a choose 5. It's always going to be one less than the term you want because we're starting off at a choose 0. So to do this one here, I'm not even going to look at my numbers. I'm just going to jump right in. And I'm going to say, all right, it's going to be a combination of 5 choose something. It's going to be a 4y to a power. It's going to be a negative 3 to a power. Now, since I want the 4th term, I'm going to do choose 3 because it's always one less. And if that's a 3, then remember this over here has to be a 3. And if that's a 3, then this is going to be a 2 so that they add up to 5. And then I can type that in my calculator, and I do that alpha window as a shortcut. It's a lot fewer keystrokes is going to be helpful. Get in the habit of that. So you got your 5, choose 3. Maybe you just knew that. That would be great. Then I'm going to have it times a 16. And then I'm going to have times a negative 27. I get negative 4320. And then it does say the 4th term, so it's going to be a y squared. Pay attention to your directions. If it says find the term, then you would go ahead and include the variable part. If it just asks for the coefficient, then don't include the variable part and just write the number. Okay, I'm going to have you try this next one on your own. So pause the video, try it on your own, then come back and check. All right, so to do this one, I got it started. This is kind of how you're going to start, and then you got to use your brain a little bit and figure out, what do I plug in on all these spots? Well, I'm looking for the 8th term, so that means since we start off at a choose 0, it's always going to be one less, so this needs to be a 7. If this is a 7, then remember that this up here is a 7, and if I want these to add up to 10, so I put a 3 here. All right, so then when you type that in your calculator, here's what I got. 2, 5, 3, 1, 2, 5, 0, 0, 0. It does ask for the 8th term, not just the coefficient. So let's include our variable parts. We got 2 variables. We're going to have an x cubed and a y to the 7. And there is my answer. All right. Now, I know the blue box here is empty, probably in your notes. So what I'd like you to do is go ahead and write in there, what are these patterns that we just came up with? How do I know? Well, I know that their sum is equal to your power. And then make some sort of note like this and this are going to be equal. And I'm writing it on top of this, but you should probably write it up here in this blue box and do it for each one of them. So that you, sorry. And how did I know it was 7? It's always one less than the term, I guess you're looking for. Something like that. That's kind of messy, but you have this great big blue box to clean it up. All right. Get to work on your homework. Good luck.